Okay, most of you will, in fact all of you, will be doing a hypothesis test. Different ones of you will be doing different hypothesis tests. So in this video we're not going to get into the different types of hypothesis tests, but we're going to be talking about a concept that is common to all the hypothesis tests that you will be doing, which is called the P-value. It's how we measure evidence. We believe the alternative hypothesis is true before we go into doing the research. However, we assume the null hypothesis is true and see how likely our data are under this assumption. Okay, so a high likelihood of the data occurring under our null hypothesis simply means the data are consistent with the null hypothesis. A small probability of our data occurring under the assumption of the null hypothesis is evidence against the null hypothesis and evidence for our alternative. Notice I've been talking about evidence and its relative strength. I have not been talking about proof. We do not prove anything using statistical methods. If our data are unlikely under the null hypothesis, then we have evidence for the alternative, just like I said. And that's kind of what you're rooting for, even though you can't sway the evidence toward that direction. As a researcher, that's what you think will happen. Otherwise, you would never be conducting the research in the first place. If our data are likely under the null hypothesis, then our data are considered to be consistent with the null hypothesis, and we do not have evidence for the alternative. So if our data are unlikely under the null hypothesis, then we have evidence for the alternative. So how unlikely do the data need to be? If something happens 50% of the time, is it unlikely? Well, no, because, there's a 50-50 chance it's going to happen. Nobody's really surprised. Ooh, that happens half the time. There's nothing surprising there. What about 30% of the time? If you're told there's a 30% chance of rain and it rains, are you surprised? What about 20%? 10%? Probably getting closer there. Actually, the burden of proof depends on the situation. For our purposes, 5% will be considered unlikely. So if the probability is less than 0.05, then we're surprised that we got our results. And we have evidence for our alternative. The evidence is measured by something called the P-value, and that really is the name that it's given. The P-value is the probability of getting data at least as far away from what we expected in the null hypothesis as those attained by the study. Okay, so it's getting results at least extreme as the ones we did under the null hypothesis. All right, typically a P-value is calculated by first calculating a standardized score. A standardized score is found by taking the difference of the summary statistic and the expected value stated or implied in the null and dividing that difference by the size of the standard deviation. Then, an area under a special curve called the sampling distribution is calculated based on the standardized score. If you have a one-sided alternative, then the area will come from one tail of the sampling distribution. A one-sided alternative is if you have either a less than or a greater than symbol in your alternative. If your alternative is just not equal to, then you have a two-sided alternative. Then the area will come from both tails of the sampling distribution. Those of you doing chi-square tests, those are typically considered many-sided, and they have a different distribution that they work with than the others. So it's kind of a special case, but the P-value is still interpreted the same way. You may be asking, well, I have to calculate the P-value. Am I going to have to do calculus to get this? Nope. The beauty of calculators and computer software is that a researcher can enter his or her data and all the calculations can be done by one of these amazing tools, which is why you don't have to have a full statistics course before you do a research project like this one in order to be able to conduct inferential analysis of your results. Will I need to interpret my P-value? Yes, you will need to be able to apply the definition of P-value to your specific P-value, to your specific case. You will also need to be able to make a decision based on the evidence provided by your P-value. If your P-value is less than 0.05, then reject the null. congratulations, you have evidence for your alternative. If your p-value is greater than or equal to 0.05, then do not reject the null. And unfortunately, you don't have evidence that supports your alternative. You have evidence that is consistent with the null hypothesis. But don't make that, if that's the case, that doesn't mean your research is faulty or that you have failed in any way. You've just found that, according to your study, the data are consistent with the null, and that's good information to move forward knowing that. Okay, guys, that's just an introduction to hypothesis tests and p-values, just to kind of give you an idea of what it is you're going to be doing with your findings when you do your inferential analysis. And I look forward to working with each one of you. Everybody's got a different set of hypotheses, and so everybody's going to have different tests, and the details are going to vary from person to person. Okay, guys, see you in class.